Hello and welcome to this lecture on the fundamentals of data. Because this is a data analysis course, we're going to be talking about data throughout the entire semester. So I want to make sure that you have the information and the vocabulary for talking about data and understanding all of the topics that we're going to be covering this semester. We're going to get started by looking at a sample data matrix. A data matrix is where we store data that we've collected. So in this table, the rows of the data matrix are observations, so individual observations that we've made. These observations can be an individual person in the study or an individual country, any sort of thing where that's the unit that we're studying. The columns of this data matrix are variables. This is information that we've collected about each of the observations in our data set. So let's make this a little bit clearer by going through this particular example. In this data set, we have information on characteristics of 60 different college students. So each of the observations in this data set is an individual college student, and we can see the left column counts up these observations from 1 to 60. I haven't shown you all 60 observations on screen. The vertical dots sort of indicate that there's data in between rows 4 and 60. Okay, so we have 60 different college students, and each column gives me a piece of information about each student. So in this case, the variables that I have in the data set are the student's age at the time of the study, the student's GPA at the time of the study, and a variable that tells me if either of the student's parents has a college degree. Each of these variables has a nickname: age, GPA, and parent univ. So let's go through a couple of these observations. Student 1, observation 1, is 20 years old. The student's GPA is 3.10, and the parent univ variable is 0, which tells me that neither of the student's parents has a college degree. Student 2 is 19 years old. That student's GPA is 2.90, and at least one of that student's parents did get a college degree. If any of that didn't make sense, there are some more examples of data sets and how to interpret the information in those data sets in your textbook reading for this week. Next, we're going to look at different types of variables, so different types of data that we might run across and use. This handy flowchart is from your textbook, and it breaks down the types of variables in a useful way. There are two primary types, numerical and categorical variables, and there are some subtypes underneath each of those. So let's look at these in turn. A numerical variable is a variable that takes on number values, and it would make sense to perform mathematical operations on those number values. So for example, you can think about the variable of your annual salary. You can understand what it would mean to subtract from that number, to add to that number, to divide that number, or multiply that number. So that's a numerical value. It takes on number values, and we can understand that performing mathematical operations on those values would also give us meaningful results. There are two primary types of a numerical variable: a continuous variable, so a numerical variable that can take on any value within a given range, a potentially infinite number of values, and a discrete numerical variable which can only take on particular number values. We're going to go over some examples of these in just a minute. The other primary category of variables is a categorical variable. This variable takes on values which are not numbers. So for example, you might want to know about somebody's gender, right? The categories male or female or non-binary or other, those are not numbers, but they are useful pieces of data. So an ordinal categorical variable is a categorical variable which does have a natural ordering to it, even though it's not a number. And a nominal categorical variable is a categorical variable like gender, which I was just talking about, which has no natural ordering. So let's talk about some examples of different kinds of numerical variables. First, let's talk about some continuous variables. One example would be a person's height. So this is a variable that we would measure as a number, height in, say, inches or centimeters, and we could measure this variable infinitely precisely. So we could measure it as just height in inches rounded up to the closest inch. So you might be 5 feet and 7 inches tall. You can think we could also measure this much more precisely. We could measure someone as being 5 feet 7.283 inches tall, or even more precisely than that. So this is a continuous numerical variable. Potentially it could take on an infinite number of values. Similarly, the GDP of a country could take on an infinite number of values in dollars and cents and fractions of cents for the GDP every year. Time is another variable that it makes a lot of sense to think of as being continuous. We could think about time as passing in years or months or weeks or days or hours or minutes or seconds or milliseconds or picoseconds. We can measure this infinitely precisely, and so a time variable can take on an infinite number of values theoretically. I do want to note that usually when we have a continuous variable, we're not going to actually measure it infinitely precisely. We're going to round to a useful unit. So we might measure a person's height in inches, or the GDP of a country rounded to the nearest 1,000, or time since the last presidential election rounded to the nearest month. Okay, a discrete numerical variable is one that can only take on a certain set number of values. So for example, if we flip a coin 100 times, that variable can't take on the number of heads that we get in 100 coin flips. That can't take on infinite values. That variable can be 0 heads, 1 head, 2 heads, all the way up to 99 heads, 100 heads. But we would never say that we got, 50.3 heads in 100 coin flips. That doesn't make sense. It's a discrete variable. We count it up and it can only take on that set range of values. Similarly, the number of people in a household, we wouldn't say that we have 4.8 people in our household. We'd say, we can have 0 people in the household, or 1 person, or 2 people, or 4 people, or 8 people. But again, it says discrete. This can only take on a certain number of values. And similarly, the number of countries in the international system. We might say that we have 193 countries in the international system, but it wouldn't make sense to say that we have 193 and a quarter countries in the international system. Next, let's look at some examples of categorical variables. Remember that we have 2 different varieties of these categorical variables. One is ordinal, a categorical variable that has a natural ordering. The other is nominal, which is non-ordered. So an example of an ordinal categorical variable would be, let's say I did a survey where I asked a multiple choice question about that person's highest level of educational attainment. And they can select some high school, they've graduated high school, they've gone to some college, they've graduated college, or they have a postgraduate degree. So this is not a numerical variable. I'm not asking them specifically like how many years of education they have. I'm giving them categorical options that they can select from. But there is a natural ordering from these. These options go from less educational attainment all the way up to more educational attainment. Another example would be if I asked someone to rank their health: poor, fair, average, good, or excellent. There's a natural ordering to those measures of your health, but it's not any sort of numerical measurement. I'm not asking them about their blood pressure or their cholesterol or anything like that. I'm asking for an overall categorical measure of their health. The other type of categorical variable is a nominal variable, or a variable without natural ordering. So, for example, gender, like I already talked about, can have the categories of male, female, or some other gender identity. Another interesting nominal variable to think about is a zip code. A zip code is usually represented as numbers, but those numbers don't mean something mathematically significant. They're just a way of categorizing a particular geographic area. And there's also no natural ordering of zip codes either. So in the Columbus area, the zip code 43214 is not greater than the zip code 43210, but they are different categories that if we want to talk about where someone is from and have them put down their zip code. And another type of nominal categorical variable would be a type of political system. If I was studying a whole bunch of countries and I want to have information on the sort of political system that country has, I could write down if that country has a presidential system, if they have a parliamentary system, if they have a monarchy that rules the country, or whatever. If you're confused at all about the differences between these different variable types, I again encourage you to consult that section in your textbook, but there are also lots of resources available, especially on the internet, that talk about different types of data. So I encourage you to do some searching around, find some other examples until the concepts are clear for you. You can also feel free to post on the discussion board on the class page in Carmen if you've got questions about what type of variable a certain indicator might be. So if you want to say, wait, is GDP a discrete or a continuous numerical variable? You could post that question on the discussion board and see the sort of responses that you get. To wrap up this video, I want to talk about a specific kind of categorical variable called an indicator variable. These are also called binary or dummy variables. There are lots of different names for them. But the essential concept is that these variables can take on one of two values. So for example, let's say that I want to know whether my subject in my study is a US citizen. I could ask, are you a US citizen? Yes or no? And then if they say yes, I can put a 1 as my value for that variable. If they say no, I can put a 0. I can do this with lots of different questions. So there are lots of potential uses for a variable like this. Lots of datasets have them. You might remember in the data matrix that was my example at the beginning of this lecture, I had a variable called parent univ that was an indicator for whether one or more of the student's parents had finished university. So when that variable was equal to 0 in the data set, that meant that neither of the student's parents had finished university, and when it was equal to 1, that meant that one or more of that student's parents had finished university. So that's the end of the presentation on the fundamentals of data. I'll see you next time.